Okay, we'll make a start now. So what I'm going to do is, first of all, talk little bit about tomorrow's test, and then I'll do some examples from tutorial sheet number 6, the beam stresses. So, and also tell few things about where you if you need any help, then how can I help you in that way. So okay, so tomorrow's test, again it would be very similar to the previous one. So this is, tomorrow would be 10th of December, and it is worth 10%, and it would be a mixture of multiple choice question as well as few other type, and one of the type I'm going to show you in a moment, that I'm going to do with you in that way. So that's MCQ for that. So let me tell you what type of questions you may expect first. So one of the type of questions that you may be given is to write something as a short answer. So I'll give one of these questions like this. So let me show you in this playground area here. So it could be something like, I give you a beam and say write down the shear force, expression of shear force and bending moment for the following beam at an arbitrary distance x from the left hand support using Macaulay bracket, and use the sign convention for shear force and bending moment, so not bending moment as shown, and what are the geometric boundary conditions. So you have to type in the answer in the box given below. So if I show you the answer, that problem is possibly that problem 2D. 2D is the problem. So let me get the solution. So this is the problem. So what you have to do is, you have to write down the expression of bending moment and shear force in that space over there, and using Macaulay's bracket. So if you click it in here and you start on typing shear force, say V, you can say V is equal to, then you can say, okay, 3.57 on the left hand side, and that is going up. So according to the sign convention I have used, left hand side is downward positive, so that would be minus 3.57. And then until x equal to 2 meter, I don't have any load. Only when x is more than 2 meter, I have got the UDL, and that is downward direction, so that is plus. So plus 2 times, and then you can use the arrow in your keyboard like this, x minus 2, for example. You can do that. That is, shear force is equal to minus 3.57 times this. In the same way, you can say bending moment M is equal to, so the expression is given there, x minus 2 square minus 3.57x. So you can write down that x minus 2, and square you can put it in this way here. If you see this one as a superscript, if you click that, that will give you square. And then you type, you undo it, then that would be, it will come to again normal one, and then say minus 3.57x. So that is one way. Else what you can do also, you can use the maths writing. So there is a symbol here, insert maths equation. So you can click onto that one, and then you will get a portal, and there you can type anything. So you can say V is equal to minus 3.57 plus 2 times x minus 2. So 2 times, now this angular bracket, if you see there are few tabs there. The first tab is if you want to do something up or down, plus or minus. Second one with the symbols. Third one with the ellipsis. This is the Greek letter. This one with if you want to write matrix. This one with the power. And this is one with the bracket. And you can see there is one angle bracket there. So if you do that one and say 2 times, what is the problem? X minus 2. That would be the shear force. And then bending moment, if you say, is equal to, again, that is x minus 2 squared. So you put that one first, say x minus 2, and then square. So square, you go to this button and then click that. That would be square. And then you press that. If you do it that one, that is a superscript, and press the right hand button or right arrow key on the keyboard, then that would be the normal one. And then you type in again minus 3.57x. And once you have done it, you say OK. Then that would come in nicely onto here. Now don't worry if you're fiddling in there. If you want to do square using any other way, so instead of you forgot about how to do superscript, if you say this is type of square like that, I take that one. And also if you're just typing, then give some gaps in there so that I know that you are using in this case. And this would be, so one thing is that you not get your marks straight away tomorrow after you submit, because these type of questions have to be manually marked. So it will take some time to get your marks. So maybe Monday you'll get the marks. So to summarize these sort of questions, either you use this third dialog point where you can insert a math equation, or you can write using the left hand arrow and the right hand arrow on your keyboard, which is on the bottom row next to M. Between the M and the upper keystroke, you'll find those symbols. So next to basically same key as the comma and the full stop in the normal keyboard pattern. So that way you can use Macaulay bracket, and that would be definitely, I'll put one of these questions. And then you say, what are the boundary conditions? So the boundary conditions, if you want to say, okay, so boundary condition you can say at x equal to 0, y equal to 0, and at x equal to 7 meter, y equal to 0, for example. And then if you put that in, that will put in everything in there. So use maths 1 if you want. And again maths 1, just to revise you, the angular bracket would be in this bracket 1. So that is first, second, third, fourth, fifth, sixth, seventh tab. And that's the angle bracket in there. And the power, you will get it through here, subscript or superscript. So superscript, you will get it here. If you have to divide something by 2, let's say you want to say y equal to something x minus 2 whole square over 3. So something like this. So x minus 2 square over 3, for example. So you could use that as well. So it will put it in that way. So that is one thing I want you to be familiar with. Secondly, again, this will be 30 minutes test. So questions would be, let me get back to the questions now. So the questions would be, one would be on the, so it will be few from the stress, and then deflection I am unlikely to give you because the time is only half an hour, so unlikely to give you find out the complete deflection, for example, to carry out the integrations and everything. It may be in the final exam in January. But not tomorrow. Tomorrow probably what I'll do is the first bit, write down the moment expression and equate it to EI, D2I, DX2 or something. So finding out the moment equation using Macaulay bracket, finding out shear force equation using Macaulay bracket, boundary conditions. So these are the type of questions you may expect. And the stresses in terms of the beam stresses, that would be few questions, a couple of questions, and then second moment of area. So stress or deflection, I'll have only the moment and shear expression using Macaulay bracket and boundary conditions. And then finally, second moment of area. Now, second moment of area, of course, you will have your books and everything with next to you. So, only thing that I'll probably be concerned with for the test tomorrow is the rectangular section, and the rectangular section with B, and if the height is h, then the second moment of area about an axis going through the middle would be BH cube over 12. That's the thing that I like you to remember. But anyway, you'll have your papers, notes, everything, and of course Google would be next in the next tab, so you can use Google as well. Yes.
Are you serious that the test is open book?
Sorry?
The test is open book?
Yeah, of course it is open book. I have not asked anybody not to bring any book. But what I said, probably that is not used, considering time is only half an hour. And of course, you have got Google next to you. You can use Google. So the questions I will set so that, for example, you have to do some amount of calculations and you will need to do that. So all the tests have been so far all open books. So I'm not going to do any of your memory tests. What you cannot do is ask the next person. So you cannot discuss with your next person. But you can, of course, bring your books, notes, anything. Okay? So if you find some notes is helpful, bring it along. Not a problem. Okay. So is that okay in terms of the test? I'm going to go to do some examples on tutorial sheet 6. But is that okay? Yeah. Material behavior, okay. I'll look at some of the questions as well. So material behavior is primarily the stress and strain. Yeah. Yeah, that is under assessment, yes. Okay. And the final thing before I move, so you may, when you are doing revision, so you may have questions, some of the questions. So what I am proposing tomorrow, although it would be late to some extent, but if you have got any final query, for example, I'd be probably taking a station downstairs near that cafe, one of the desk there, from around 1:30, 2 o'clock. So if you have got any questions, burning questions before the test at 4 o'clock, do come along. So I'll be there next to the downstairs cafe. Yeah.
During the test tomorrow, are we going to have some multiple choice questions?
Yeah, you will have some multiple choice question, yes. You will have some multiple choice question and couple of calculation question. And one of the calculation type would be writing a short answer like that. Okay? So that's why I demonstrate to you. Yes. I cannot hear. Yeah, some multiple choice could be more than one answer possible. So there are normally two types of radio buttons in MCQ test. In MCQ test, if you have got these circular buttons, then that means only one answer. Only one answer. So you can choose only one. But if you have got a square button like this, then more than one possible. So more than one possible. And in this case, there would be negative marking. Just because somebody can tick all the boxes and that will contain all the right answers. So if there is square button, then there would be negative marking for those. So you answer only which one you think is correct. But if the circular buttons are there, that means only one answer, there will be no negative marking. So give it a go in this case, even if you faintly think, okay, that is right or that other one is right. Okay, so it will be fairly okay test. So I don't expect you to struggle with the test tomorrow. So I expect a better performance, but you will not get any answer immediately after submission. Second moment of area will be there in the syllabus, yes. Only for this test you need to consider a rectangle, nothing else. Only a rectangular section. But I may give you a problem like this, that you have got an I section and you have got a rectangular section and you have got a circular section, all have same area. So all have got areas, the total area is the same. So which one you think would have higher second moment of area about this plane? So that type of questions could be there. So you don't need to calculate, but you need to choose one. So of course in this case, highest second moment of area would be for the I section. So as much material away from the axis, they would have higher second moment of area. Yeah, so that is because area times d square. More materials away from the axis. Yeah. That has got higher second moment of area. Yeah. Okay. Even if I give you two I section, so one I section has got a thicker wave and another I section has got thicker flange. Say, and if I say, so this has got thicker flange, so this side is thicker than and this has got a thicker wave. Now if you calculate both our area are the same amount of material, this will have got higher I value. Because more material is away from the, this will have higher I value because more material is away from the central axis, from the axis. Okay. So use that idea there. So if you have got the same area similarly, and if you have got a rectangular section and a diamond section, same area, then this has got higher I, because here more materials are towards the center, for example. So some multiple choice questions around that line would be there. Is there anything else regarding the test? Yeah? This one, you mean? Yeah, this one, if you have, say, there are two correct answers and you do one, you will normally get half of the marks. Or if there are three correct answers, if you do one, then you will get 1/3 of the marks. Okay? But it will never be negative overall, so it will be 0. If you click all the boxes, then it will be 0 primarily. Yeah, I'm coming to the stress. I'm coming to the stress. Okay, so that's the formality, and I'll be near the cafe downstairs tomorrow from roughly about 1:30. I have to come from the other building 1:30, 1:45. About that time till your exam starts, so till 3:45 there. So if you have got any questions, last minute thingy, then or query, do see me there. Okay, now let's go back to stress. Let me bring that to me. Okay, so stress. So this is what you need to know for tomorrow and for the rest of your structural engineering career. Okay? So let me use my colored pencil, so that is better. So if you have a member like this, and you put a load onto it, then it will generate stress onto that member. And this stress is called axial stress. So it is acting along the axis of this member. So this is called axial stress. So this axial stress would be equal to the load that you apply. Let's say this load is force F. So this axial stress will be the load that you apply, which is F, divided by the cross-sectional area. So A is cross-sectional area. So if it is rectangular section, you find the cross-sectional area, and then that is F over A. So if the force acts along the length of the member, that will generate axial stress. And how do you find axial stress? Axial stress is F over A. Now this axial stress could be either compressive or tensile. So the direction that it is shown, so it could be either compressive, so which happens push type of force. So for push type force, or it could be tensile. And tensile is primarily pull type force. And depending on that, some people use as plus or minus sign. So normally people say, okay, if it is tensile, it elongates, and then it is positive. If it is compressive, then it is negative. Now, if you do some other subject, for example, some of you are civil engineers here, when you do the geotechnics or soil mechanics next semester, they will say, well, compressive is positive because soil cannot take any tensile stress, so they consider compressive as positive. So, sign convention you need to soon get used to, that people use different sign convention depending on the circumstances they are dealing with. Okay, now which is the direction of these forces and stresses? Now to do that, what you need to look at, yes, you raised your hand.
You said about the direction. The direction of them in the diagram is compressive.
In this direction, this force is compressive, yeah. So F is compressive in this case as shown. Okay. Now in that sense of direction, often in all cases what we need to know is you have got a structural member, you put a load, and two things you need to find out. One thing is the stress. Why? Because if the material is sufficiently strong enough to resist that force, so you need to find out the stress, whether the material will crumble, for example, into this compressive force. Or if you put a tensile force, whether that will tear apart, for example, due to that forces. So you need to find out to check whether the material can resist that level of force by checking stress. Other thing what you need to know is deformation. Deformation is critical because it can generate, if too much of deformation can generate cracks, can be deflection could be too much, which makes it beyond its usable limits. For example, I would not be confident in walking on this floor if it was made up of some fabric. So I put one foot and it dips down, another foot, it dips down. That would be too uncomfortable and it would be beyond normal use and expected use for that type of structure. So deflection, although that is safe, I am not going to fall through that membrane, but still it is deflection wise, it is not right. So what happens in this case, the deformation? So if you take a strand, for example, here, if you take a strand in this direction, so I take, say, let's say these are the strands of this height. So if the strand originally was this height, and if you applied the stress is compressive like this, then this strand will shorten. This strand will shorten. So the stress acts along the perpendicular direction. Now, if this strand was under tensile force, if this strand was under tensile force, that will elongate. So if you imagine the member is made up of lots of fibers, so if you pull a tensile stress, each fiber will extend. So the stress acts in the directions of this, length or axial stress. That's due to Poisson's effect, but that strain that happens, that is true, that the stress will the area would be, if in this case it will fatten up, the cross-sectional area will increase, and if you put tensile, then cross-sectional area will decrease. But in calculation of the stresses, we never take the reduced or increased cross-sectional area. So this nominal cross-sectional area is always used. So A is the original cross-sectional area. So original cross-sectional area is always used. Stress will change with the Poisson's effect, yes. But for calculations, we never take, even when we do the material testing, we always calculated our yield strength or ultimate strength based on the original cross-section. never ever with the reduced or cross-sectional area. So that way we are consistent. Okay? So that is if you apply a load to a member which goes along the axial directions and whether it is tensile or compressive. So that is one aspect of the stress. The second aspect of the stress is that if you have got this member, let's say, I could do it with why I'm doing this way. Okay, let me do it in the vertical way only. So if I've got the same member, but this time I am applying a load which will induce shear. So I'll add load in this direction which should be balanced by a load like this. So this is going to introduce what is called as a shear stress. So if you consider this effect, of course it will create bending as well, but besides bending, this will create shear stress. So the shear stress is, again, I should use the term average because this will vary. So this is also average axial stress because it will vary on how over the cross-sectional area. Average shear stress would be, so if you say this is V, so average shear stress is again V over the cross-sectional area. And how this would act? Now to do that, we need to take out two sections from here. So if you take these little elements, and I show it in here. So this is my sections coming from this point. So on the top side, shear stress acts just being a pedantic and consistent. So this is shear stress. So acting on the surface itself rather than as a load. Okay, so shear stress, so if this is V, then this would deform in this way. So the deformation is in this way. So it will change the angle. It will change. So this side was perfectly vertical. This changed to the angle. So how this will look like if you have a shear force going in this way. Now if you consider from the middle, for example, this would go something like that. Then if you say, okay, next one could be something like this. Next one could be something like that. Next one could be something like this. So it will go on. So if I have that one, so this is the deformation pattern that we could have. If you imagine, of course this would be the continuous one. So if you imagine this is made up of blocks like those, number of blocks this tower is made of. Then if you apply shear at the top and the resisting shear at the bottom, this is how they will slide. So shear, the term, is related with the sliding with respect to the next one. So it's a sliding motion that would have. Now, in terms of the expression, it's exactly the same. F over A and V over A. So V is the shear force, A is the cross-sectional area. So average shear stress is V over A. In terms of the distribution, it's slightly different, and you will learn that in your second year. But in terms of the expression, what is the stress? Exactly like this. The shear stress is V over A. Now, would you get a shear stress? Now, of course, if you have got a column like this, for example, if you have got a column like this, and you have got an inclined load at the top, for example. And that inclined load you can think of made up of a vertical load and a shear load in this case. So if a load is inclined, that will generate an axial stress due to this component and a shear stress due to that component on that member. But the expression is exactly the same, F over A and V over A. Third problem is bending. So let's say again you have got a column like this. And this time you are applying a bending to it. Can you see that? Yeah. So you apply bending to it. Let's say this bending is you are applying as M. Now, first thing, what is the formula for this bending stress? It will generate bending stress. So the bending stress formula is bending stress we calculate by sigma. Now, the Greek letter for this shear stress is tau, and axial stress is given as sigma, and so is bending stress, because they act in the same direction, along the length direction, but the shear stress acts parallel to the cross section. So tau acts parallel to the cross section. Parallel to the cross section. So this is the parallel to the cross section, this act. And sigma acts perpendicular to the cross section. So bending stress also acts perpendicular to the cross section, and its formula is sigma is m over I times y. What does each one means? M is the bending moment that you are applying. What is I? I is the second moment of area. So if this is your cross section, so this is the cross section. So cross section, that means you are looking from the top. So in other words, this is something like, let's say this is the beam. This is the beam, for example. So you are looking from top, and let's say this dimension is B, for example, or rather say D here. So this dimension is also D, and this side is say B. So this side is B, for example. This side is B. So it is bending about this axis. So I, or the second moment of area about this axis, is B times D cube over 12. So this dimension is B. This dimension is B. And this dimension is D. So if you look from the top, this is the cross-sectional area. And what is Y? Y is the dimensions from the neutral axis, from the middle plane. So Y is this distance or that distance. So that could be positive Y and this could be negative Y. So it could be one side tensile, one side compressive in that way. So you need to find out first of all cross sections, second moment of area, and at what point you are calculating the stresses. So the stresses you are calculating at this point, so the maximum would be there. Now how it will vary? Now if you take a line from here, and let's say I draw that line again over here, and this is the middle point over at this point. Then if you consider few fibers over this length, let's say I consider few fibers. I consider few fibers along that length. So let's draw those fibers along that length. So these fibers are going along the length of the member. Now this bending, what it will do? So that this bending is going to, so let's say I put that one line again, and I have applied a bending which is like that way. So effect of that bending is to reduce this side's length. So this length would be reduced. The middle one would be the same length as before, but it will continuously reduce as it go along that side, and it will start to increase over the other sides. So the fiber at this end will elongate. So you will have tensile stress in this side, and fiber on this side will reduce, so you will have compressive stress in this side. And the maximum is from the farthest distance that you go. So if you imagine this column was made up of lots of fibers, so from the middle one, so absolutely the middle one is here. So that stage unknown. So the middle one does not change. Middle one does not elongate or contract. Whereas if you go towards the right hand side, due to that nature of the bending moment, it will start to shorten. So it will have sort of this compressive stress that we are talking about before. So it will start to have compressive stress, and the amount of contraction will increase as you go further up or further to the right more and more. Whereas if you go on the other way around, each fiber will start to elongate. So what will happen? So the beam or this column as a result will bend. Because if it bends, then it will have it. So by this elongation, differential elongation and contraction, the beam will bend. So it will have this side a concave and the right side will have a convex side. Is that clear? Conceptually. So problems are exactly, if you understand these problems, you will not have any problem, any difficulty in getting. So find out what is the bending moment at any location. So if you have to find out the bending stress at a location, find out what is the bending moment. You know that. You have given the geometry. You find what is the second moment of area. And if you are given maximum compressive stress, you find out, you choose the value of y, which is maximum from the central to this one. So this is the value of y you are talking about. And if you are given the asked to find out the maximum tensile strength, then this is the value of y you should consider. Always from the central plane. Central fiber which does not change its length, does not elongate or contract. So from there you find out the y either going up or down, and then that will get you the stresses. So compressive or tensile. So you need to have an idea about which side if you bend, and you will get different values. So in terms of the problems, exactly the similar problems that you are given. You find out second moment of area, and in this case you need to find out the bending moment, maximum bending moment. Now maximum bending moment in this case will be at the middle. And if the load is 2 kilonewton per meter, then this maximum bending moment is given as 2 times the span square over 8. Now I know the formula, you don't need to know the formula, you can find out how much it is, and then that much kilonewton meter. So W is or Q is the load intensity times the span square over 8. That's for this bending moment maximum. So you will have a maximum stress at that location. So you know I, which is about this axis, is 1/12, B is 50, and this is 150 cube, that much millimeter to the power 4. So convert kilonewton meter to Newton millimeter, for example, or millimeter to the power 4 to meter to the power 4. Choose a unit which is consistent and then find out maximum stress is sigma is m over I times y. M value you know, which is there, I value you know, y would be maximum in either here or there. So either y equal to 75, and that will give you compressive stress at this top, and y equal to 75 negative 1 if you do, that will give you tensile stress at this bottom face. So again this problem you find out what is the maximum bending moment. So the maximum bending moment could be, in this case, could be something like this. So you'll have one bending moment here which could be maximum, and one bending moment could be maximum there. You can find out by drawing the shear force diagram. This may not be necessarily in the middle. So look at the solutions, and drawing the shear force diagram will give you the location of this maximum bending moment. Here you can find out the maximum bending moment which is due to this load. So you can easily find, if this is 2 kilonewton per meter, this bending moment would be 2 times 1.2, that is the total load, and that will act as half of a distance, so 0.6. So 2 times 1.2 times 0.6 kilonewton meter would be the bending moment at that wall. So similarly you can find the other bending moment and then use that to calculate the stresses. But most importantly, it's not this solving this problem, this comes secondary. If you know how to calculate bending moment diagram and the values, then understanding this is absolutely important, because often students find out, what is this y? I know what is bending moment m. I know what is I. What is this y business that is doing in this point? So that is, you need to consider in this way. Yeah.
Why is supposed to be the height of this? Supposed to be halfway up the height of the specimen?
Yeah, it could be half, or if the section is not symmetric, it could be one side bigger.
If the y is the centroid.
Y is the center, from the centroidal axis to the distance from the outer fiber. You are going to ask that one. So if you have got a cross section which is not symmetric, let's say you have got sections like this. Say if you have got a sections like this. So the centroid could be there, and then you could have this is the centroidal axis. You calculate I about this axis. So so this fiber stress could be, let's say this is y1. So the stress in here would be sigma over m over I times y1. Whereas the stress at this face would be, let's say this distance is y2. So that would be sigma over m over I times y2. So that may not be the same. Okay? So y1 may not be the same as y2. So the stress would be higher at the bottom surface. The I section is symmetric. So that would be, top and bottom would be the same. One should be? Oh, second moment of area for I section. So these distances are normally equal if it is symmetric axis. So then the stress at there would be same as stress at there. Is that okay? Oh, I see. So what you can do is, you can take this I section is made up of that minus two of those. Minus two of those. So if this is B and this is D, you know this is 112 BD cube, And if this is B1 and that is D1, you know that is 112 B1 D1 cube. So the total I would be BD cube over 12 minus 2 times B1 D1 cube over 12, where this is B1 and that is D1.
Just wanted to say thank you for all you've done for us.
You are happy?
Yeah. Just wanted to say thank you.
Most welcome. Thank you. It's not moment, it's the cross section, say. So if it is a rectangular cross section, then the second moment of area. So if you have got a rectangular cross section, so imagine this is the beam. So this side is B and that side is D, and you are applying and you get a bending moment at this section. Let's say at this section you have got a bending moment, let's say M. That is a bending moment. So the stress at this level, which is at the bottom surface or the top surface, would be given by this formula. Sigma is equal to M over I times. M is the bending moment at that location, along the length, that location bending moment is there. I is the second moment of area of this cross section. So which is, this is the axis of bending. So I is equal to B D cube over 12. Width times depth cube over 12. And Y is the distance from, so if this is that, if you go that way, you will get a maximum stress at that level. Depending on if the bending is that way, that will be tensile. If the bending is other way, that will be compressive.
Could you ask us like at a certain Y value, so like not the maximum?
Yeah. So if you want the stress at that level, then that would be Y.
Okay.
So it's all related to this formula here. So if you want to find the stress at that level, then Y is only that much a distance.
I have a question.
Yeah.
Like for the one that you say, like for the max moment. I think.
Maximum moment. Maximum
Yeah,
moment
because, like,
is.
I don't know like what's Q, what's P.
How did you get
So if you have got this as, say, Q per unit length, okay? So and say this distance is length L.
Yeah.
So what is the total load?
Yeah.
Total load is equal to Q times L.
Yeah.
So this reaction force would be QL over 2.